Hey everyone, Terry Vinson back with another portion of our discussion where we're going to start being able to focus on some of the technologies that we've only loosely discussed up to this point. Keep in mind, we explored exactly what took place when we ran OSPF in a non-broadcast multi-access environment. And the best example of a non-broadcast multi-access environment that we have in the confines of routing and switching version 5 is going to be the idea of a multi-point VPN configuration known as Dmvpn. That stands for Dynamic Multi-Point Virtual Private Network. Now what we're going to see here is that we're going to use a typical arrangement of devices to create a topology to work with. So just like every other course that we've had, every other class that we've had, we're going to talk about everything from the very beginning all the way to the very end, and we're going to begin with the theoretical components. And there's no better way to start with a conversation about Dmvpn when it comes to being able to illustrate what's happening. Because what we're going to find out here is we're going to use a number of solutions that we've discussed up to this date. Now, what do I mean by that? I mean, what we're going to find is that we are going to take our arrangement of devices, the device configuration that you see behind me, and we're going to create a service provider cloud. And that service provider cloud is going to allow us or afford us interconnectivity between our devices. Now obviously we're running an IGP internal to this configuration, and we're also going to have to recognize the fact that inside of that IGP we're going to be running this concept of Dmvpn. Well, what is a Dmvpn? Well, in the confines of our conversations regarding OSPF, we focused on the idea of a tunnel. Remember, a tunnel allowed us to be able to repair discontiguous areas or discontiguous area zeros. It was another tool in our toolbox, very similar to something like the virtual link that we discussed in that portion of our conversations. This is no different. However, there's a twist. Because in the confines of Dmvpn, we're going to find that we're going to be using a special type of tunnel that's going to be terminated on either or both end as what's referred to as an MGRE. That stands for multi-point GRE interface or GRE tunnel, so generic router encapsulation interface. Now, what this implies is that inside of the concept of this virtual cloud that we have, what we're going to do is we're going to create a series of GRE tunnels. Those tunnels are going to extend across our service provider cloud to each of our individual devices. Now, it's through the creation of these tunnels that we're going to afford this idea of connectivity. And initially, in the very, very beginning of time when we set this type of thing up, we would use a series of point-to-point tunnels. Now, the issue is if I use a series of point-to-point tunnels and I were to come along and add, say, a fourth router, say R7 in this scenario, and connect it to this cloud, well, I would have to do configuration both here at the hub and here at this new spoke. Now, that is okay for 3 or 4 devices, but if we have a GRE environment or a multi-point GRE environment where we have lots of connections, let's say we had 1,000 connections, then what ends up happening is that our configurational and administrational requirements on the hub become more and more complicated. And if that means that this translates into a scenario that's just not very stable. So when we look at this, we want to consider this idea of stable and highly available, so HA. So when we start delving into exactly what's happening here is we're going to recognize the fact that we are going to need a number of technologies. The first technology that we're really going to need is going to be an idea of how we resolve endpoints. So we have this interconnection of devices that are going up to the hub, but how does the hub know about the identity of the spokes without us going in and doing some specific configuration? And that's going to mean that we're going to need or employ a technology that we're going to have to become very familiar with in the confines of version 5, and that's going to be NHRP. That stands for Next Hop Resolution Protocol. Now, Next Hop Resolution Protocol is really similar in behavior to some of the other protocols that we've already talked about up to this point. For instance, we talked about the designated router in the context of OSPF. It's going to be a pseudo-node, a virtual device that sits inside of a device, could be hosted by multiple devices on an Ethernet segment in the context of OSPF, that allows that one unit or that one virtual entity to act as the centralized point of management for shared connections, thus restricting the amount of stateful entries we need to maintain in order to have communications in a broadcast environment. Now keep in mind, I mentioned earlier that DMVPN is an NBMA. It's a non-broadcast multi-access environment, and we're going to have to understand how we can overcome certain hurdles. Now, in the confines of our EIGRP conversations and our OSPF discussions, we saw how we could take a pre-configured DMVPN environment and run our routing protocols on top of it. We skirted all of the details associated with DMVPNs until now. So what we're going to be doing is we're going to add the missing component to our understanding in order to be able to construct first of all, a very simple configuration. In fact, in the confines of the CCIE Routing and Switching version 5 exam, we only need to concern ourselves with single hub topologies. And we are also going to have to recognize that there are 3 operational phases to DMVPN. Let's look at those. Phase 1. Phase 1, quite simply put, is going to be where we create a connection like we have right here, where this device can communicate through the cloud up to the hub and go through the hub to reach other devices. We do not have the idea of spoke-to-spoke connectivity in the confines of a Phase 1 DMVPN employment. So that's the most important element there. A lot of people get this process confused. Phase 1 means I built a DMVPN environment where I have spoke-to-hub reachability. Any spoke-to-spoke configuration is going to have to go up to the hub and back down. Now, that's not very efficient. Why? Because when we look at this, what we're doing is we're creating a bottleneck right here. We're creating a bottleneck that can cause us significant problems when we start thinking about exactly how much traffic we're going to be placing to that hub. Meaning every traffic that's coming from a spoke to another spoke has to travel up to the hub and back down. So in other words, what we're doing is we're eating up a lot of our bandwidth. That's why we deployed this concept of Phase 2. Phase 2 DMVPN is a deployment whereby we get the capability of creating spoke-to-spoke connectivity through the deployment of dynamically generated multi-point GRE tunnels between the spokes. So not only is it from R4 to R5 and R5 to R6, we could even and would even have a connection to where R4 would be connected to R6. So in a Phase 2 environment, dynamically we can create the equivalent of a full mesh topology. Now, we're not talking about circuits or virtual private circuits or switch virtual circuits like we did in frame relay, but we can see the similarity with regard to behavior. And the fact that by tying all of these things together, we're creating a scenario whereby we can have devices that think that they are adjacent for the purposes of layer 3 communications, even though they're separated by a large service provider cloud. Now, the last phase in this process is considered to be Phase 3. Well, what is Phase 3? Well, many people want to tell us that a Phase 3 DMVPN deployment is going to be a deployment whereby we add security, IPsec. Well, in all honesty, that couldn't be the furthest from the truth. Because what's going to happen here is that we can put security in a Phase 1. We could put IP security or IPsec in Phase 2. In the confines of Phase 3 DMVPN deployments, all we're looking at is high availability, stressing that idea of HA. High availability translates to the fact that we can have multiple scenarios whereby we have these different types of interconnections. So in a situation whereby I have one hub, so let's say this is R1, this is R2, and we have a cloud connecting these devices, what would happen in a scenario where I had other hubs? So let's say we have R3 as a spoke, not hubs, R4 as a spoke, R5 as a spoke. Now inside the confines of this cloud, we can create tunnels such that our individual devices can be connected. Now, the thing that we need to understand here is that also we've discussed in the confines of our conversations other protocols, things like VRRP, Virtual Router Redundancy Protocol, HSRP, Hot Standby Routing Protocol, even GLBP, Group Load Balancing Protocol. But for the confines of our conversations, let's focus on these two. Now, if we were to take these components and connect them on a shared network whereby one is going to be active and one is going to be standby using either VRRP or HSRP, we can create a scenario now where we have the capability of getting data off of this network segment or into this new network through either one of these two different devices. And the thing that we need to understand is that we have to recognize the fact that we can do that using the same individual physical connections, or what's referred to as the NBMA connection, that we have on all of the individual devices. So in this instance, it might be FA00. As we can see, we can create these dynamic and these these dynamic or static Dmvpn connections, these tunnels on the same interface. So we need to worry about how do we make certain that the router delineates between one particular stream of traffic and another stream of traffic. These are all the things that we need to understand, and in order to be able to do that, we're going to have to move to the console in order to be able to leverage all of these interior and all of these individual capabilities in the context of Dmvpn, dynamic virtual or dynamic multipoint virtual private networks. So what does it boil down to? Phase 1 is spoke to hub connectivity. Phase 2 is dynamic spoke to spoke connectivity plus the existing connectivity that we had before. And phase 3 Dmvpn boils down to high availability scenarios where we can employ broader scopes with regard to routing protocols, where we can run first hop redundancy protocols, any tool that's going to allow us to enhance the functionality. Keeping in mind that we're able to do multiple Dmvpn tunnels across individual physical interfaces, the NBMA connections is what we're going to refer to them. We're going to have a Dmvpn connection and an NBMA connection. And we're going to also have to recognize the fact that our different routing protocols are going to behave differently. As a perfect example, if we go back to the original illustration, this physical interface, or these interfaces right here, in this drawing, are 3 independent tunnels. What we would end up actually having happen, and I'll go ahead and just erase this part right here, is that these 3 tunnels would actually, or these 3 virtual tunnels, would coalesce on one virtual interface, a tunnel interface. Let's say tunnel 0. And tunnel 0 would be a MGRE connection. So in the confines of phase 1, I have regular GRE tunnels on the spokes and a multipoint GRE on the hub. In phase 2, I'll go ahead and change pin colors to illustrate a phase 2 connection. I'm running MGRE all the way around. So there's MGRE configured under the individual link, the virtual or the tunnel interface that we configure on each of the hubs, and also, each of the spokes, and also on the hub. So keeping in mind the way all of this operates and interoperates depends on what our design model is. In order for me to get that concept of being able to send traffic directly from a spoke to another spoke without having to send the traffic to the hub, I need to have MGRE capability so that I can get that multi-GRE connection, multiple GRE tunnels on one logical tunnel interface. So in other words, all we're going to do is go into it and specify the particular type of tunnel as being GRE, and then it's going to be multi-point configuration. Now, the other thing that we have to understand here is that this is a dynamic process, and I mentioned that pseudo-node style configuration. The way I want you to think of it is this. If in the context of R2, think of the fact that I have a little server running here now. This server is referred to as an NHR server, a next hop resolution server. Now what will happen is that our individual spokes are going to be statically configured with the identity of the hub. They're going to be told where the NHR server is, And they're going to know that in order to participate in this multi-point GRE configuration that is DMVPN, they're going to have to register with this logical entity that exists on the hub. The moment they register, they're going to tell the hub who they are and what addresses that it would use to reach them. Now, once every device, R4, R5, and R6, has been added to this topology, what we're going to find is that the hub now knows all of the information, and it's going to communicate that information back down to each of the spokes, so that the spokes now will have the capability of being able to identify how to reach each other within the service provider cloud. It's going to be involving a series of dynamic or static mappings that we can utilize if we want to override the actual dynamic behavior. But if left alone, this process is beautifully simple and elegant in deployment and operation. And we're hoping that we'll be able to appreciate that once we start turning to the command line interface to see what's involved in making all of this happen.